So chapter 3 is where we start talking about random variables, which you're now super pros at all the time. You're good. So these random variables are essentially a map where we go from our possible outcomes to the probabilities of those outcomes, right? We've got our possible outcomes of X and then our probability maps for these outcomes, right? Called PMFs or PDFs once we get into continuous variables. A PDF is the probability that the random variable takes on that value, right? Our CDF is the probability that the random variable takes on any value up to and including that value, right? So mini example, suppose that we have a random variable kind of defined by this following PMF, right? So X can be 1, 2, or 3, and the probability of X being 1 is a half, the probability of X being 2 is a fourth, the probability of X being 3 is a fourth, right? So the value of our PDF of X at 2 is 1/4, right? The probability that X equals 2, that's our PDF, is 1/4. The value of the CDF at 2 is the probability that X is less than or equal to 2, right? Which is the sum, in this case, because we're in discrete, right? So we have to sum it up of I equals 1 and 2 of the probability of Xi, right? So the probability that X is 1 and the probability that X is 2. I'm a little sloppy with my notation there, but hopefully you're understanding where this is coming from, right? The probability that X is less than or equal to 2 is the probability that's equal to 1, and plus the probability that's equal to 2, right? In this case, that would be 3/4. So we don't always want to have to define our random variables this way, right? This is kind of clunky. If we always had to do that, nothing would ever get done. So we have these families, right? These binomial, like binomial or Poisson or normal or exponential or Cauchy or chi-squared, or there's a gajillion of them. Look at the Wikipedia page, right? In this case, for discrete random variables, we're pretty much only looking at the binomial and the Poisson. We also did hypergeometric and negative binomial, I think, but those are kind of tricksy with the parameterization, so I'm not really focusing on those for this exam. Essentially what they are is they're a way that we are defining concisely a PDF without having to do this row by row thing, right? So you're given parameters, right? You're given these parameters like a binomial NP, right? That tells you exactly what the PDF is, right? There's a function. I didn't put the functions in the document, but essentially all you need is this one parameter, and that tells you what the whole PDF sounds like is, right? What the probability is of all of these different values, right? So all the families have different parameters that they use, right? Binomial has an N and a P. A Poisson has a lambda, right? And then from that, we have our formula. We also have, for the formula for the PMF. We also have a formula for the expected value and the standard deviation of a random variable that follows that distribution, right? So if our random variable is binomial with NP, the expected value is N times P. If our random variable is Poisson with lambda, some value of lambda, its variance is lambda. Right? Like we just are able to calculate these things about that random variable. It's just this known quantity. You need anything? Okay, sorry. There's different versions of these for each of these families, right? There's formulas for the expected value and variance for each of these. I'm not going to list them all here. You got to go find it, right? But we can use R, right? Not even knowing what these formulas are, we can use R to compute the PDFs, right, with our little D, the name of the family function, and our CDFs with P, the name of the function, or the name of the family, for these probabilities, right? So that didn't work, which is annoying, but I will go, let me go ahead and switch to R, and then jump down to chapter 3. All right. So if I wanted to compute if X follows Poisson with lambda 4, right? If I wanted to know the probability that X equals 3, this is the PDF of X at 3, which is D Poisson 3, 4, right? X and lambda. That's my probability. Right. If I wanted to know the probability of X, this is less than or equal to, let's see if I can get it to hover for me. Yep. Probability of X less than or equal to 4. By definition, that is the CDF at 4, right? So then I need my P Poisson for 4. So this one is a little bit more tricky, right? Because this is not 1 minus the PDF at 2, right? Because I'm talking about discrete space, right? The 2 gets in the above side, right? So if I'm going to do 1 minus the complement, right? Remember when I'm working with probabilities that are above, if I want 1 minus the complement, I need to do 1 minus P Poisson 1, 4, right? Because the probability of 2 is in our set that we want to take the probability of, right? So 1 and below, here, let me go ahead and throw this here, or no, maybe up here. This is equal to 1 minus the probability that X is just is equal to this, which is actually also equal to 1 minus the probability X less than or equal to 1, right? Because in this Poisson discrete case, it can only take on values 1, 0, 1, 2, 3, right? So these two statements are equivalent, which is why I'm computing it this way. All right. So hopefully computing these guys is still familiar.
It's not to me. I have a question about that.
Okay.
You said that's from chapter 3, but I'm looking at chapter 3 and I don't see any of the problems we did like that. I have it where we have binomial probabilities. Is that similar?
Right, so this is just the example for Poisson, right? If
Okay.
you wanted, let's say we have another random variable y that follows a binomial in 5.2, right? If I wanted to find probability that y is less than or equal to 2, then I would do that the exact same way, right? So here, let's just say equals to 2, right? The probability that y is equal to 2 would be, instead of d Poisson, it's d binom. And then I have my thing I want to find the probability of, and then my two parameters, 5 and 0.2, right? So Poisson, I only need the one parameter for. So I only put the one parameter here. Binomial has 2, so I have n and p.
Okay.
Right? So it's the same I just switched out the family I was showing for. Kind of trying to show that they're interchangeable because I know we did a lot of work on binomial.
Yeah, I just didn't see any examples on Poisson, so I was just wondering, like, how does it work if it's like probabilities x is greater than 4? Would that be something like that where you had to subtract from 1 and add them all together? Or that's not the same thing?
So you're saying with the binomial, with the probability y is less than 4?
No, I have an example here where x is greater than 4, but it says at the beginning x is binomial parentheses 20 comma 0.05.
Mm-hmm.
So
Right.
then you,
So that's n and p.
okay. But then you were supposed to figure like each part out and subtract from 1. Do you do the same thing with the, like, say the Poisson example you gave us was 20 instead of 4.
Mm-hmm.
Would you do the same thing if I was calculating x is greater than or equal to 4?
Okay. So this 4 is different than this 4.
Okay.
This 4 is lambda. Oops.
Okay.
Right. So maybe I'll make it 40. If lambda is 40.
Okay.
What would change down here is this 40. Right? So the probability that x is less than or equal to 4 is the value of the CDF at 4. Hey, cut it out. Right? So I calculate that with this P Poisson, right? So the P is the one that gives us the value of the CDF function of 4 and 40.
Okay, is that equal to 4? At 4, is that equal? Or that's less than or equal to?
That is less than or equal to 4. If
Okay.
you want the probability, right?
Okay, and then what if I wanted the probability of greater than 4?
Then it would be 1 minus greater than or equal to.
Okay.
Right, so 1 minus the probability of less than 3, less than or equal to 3.
Okay.
Would be, so it would be P Poisson 3, 40.
Okay, I'm sorry. I got it.
You're good. Would it be more confusing if I point out that this answer is the sum of D Poisson from 1 to 4? Right, so this is the PDF at, right? So that's where we're talking about here, where, so this is what tables look like, not in HTML. Right, so the probability of 1 is a half, 2 is a fourth. So the probability of less than or equal to 2 is the probability of 1 plus the probability of 2. Right, so that's these D numbers are finding the equal to probability, and the P numbers are finding the less than probability.
Okay, so if I said
Or
equal
less
to
than or equal to.
it would be D Poisson 440, right?
Equal to 4, yes.
Okay.
I'm sorry, you said the P numbers look for less than
Less than or equal to.
or equal to the P numbers, and the D look for the equal to.
Equal to. Yep. And that's only important in discrete world. In continuous world, those are the same answers. Sorry, the less than or equal to is the same as less than in continuous world for reasons I'm not going to explain. So you only have to worry about that in discrete stuff. When you get to continuous stuff, the less than or equal to or greater than or equal to is pretty interchangeable. We'll talk about that in a sec, right? So I'm going to move on. How are we feeling? Just practice finding some of these probabilities with binomial distributions. Remember, I could also ask you to find the probability of x being between 2 and 4, right? And if that's the case, kind of the easiest way for me personally, okay, let's go back in our Poisson example, right? So 2 less than x less than 4. The way I think of that, the easiest for discrete variables, right? Not for continuous ones, but in discrete case, I find it easiest to just be like d Poisson 2 through 4 and then 40. Oh, nope, we'll go back to 4. Lambda is 4. And then, okay, so this guy this is the probability that it's equal to 2. This is the probability it's equal to 3. This is the probability it's equal to 4. Let me throw in some equals to, right? So if I want to find this probability, I take the sum. You could also do that here. This was I was worried about being confusing, but I'm going to do it anyway. I think Poisson starts at 0, so the sum from 0 to 4, lambda equals 4. Right. So these are going to give me the same answer. So these two, oops, these two are these two. Right. So the CDF at 4 is the same as summing the PDF up from 0 to 4. Okay. If that made you more confused, please ignore it.